Okay, so today I want to go over empirical formulas. So we went over percent composition, and if you remember, those calculations are pretty straightforward. Empirical formulas, though, are a little bit more complicated. So when we look at a formula, if you remember with ionic compounds, we always reduce the subscripts to the lowest whole number ratio. So if you remember, we said that ionic compounds have empirical formulas. So here we have a formula for molecular compound C2H6, which shows you the actual number of atoms. If we were to reduce that to lowest whole number ratio, this second formula would be the empirical formula. So we're going to go over how chemists determine this from experimental data. So the steps for this, and you'll want to write these down, and after you've done some of these problems, you'll start to remember these steps. But at the beginning, you probably will need to refer to these steps. So first, you're going to find the mass, or you could start with the percent of each element in your material. You're then going to convert the mass that you have to moles of each element. The next step is you're going to figure out which one has the smallest number of moles, and you're going to divide the moles of each element by that smallest number to find the subscripts. And then when necessary, if you do not have whole numbers, you're going to multiply the subscripts by 2, 3, or 4. It's usually going to be 2 to get whole numbers. So what you're really trying to find is you're trying to find a ratio of the elements to the smallest, the element with the smallest number of moles in your compounds. So if we look at the previous example, so I'll just flip back here, we have here, there's a ratio of 3 moles of hydrogen for every 1 mole of carbon. So we're trying to get one of the moles to 1 and then finding the other ones as ratios of those number of moles to that smallest number of moles. Okay, so let's look at a problem. So here they're giving us the percent of each element in our compound. So what we're doing here is we're assuming that when we do this problem, that we're assuming that we have 100 grams of material. If we did assume this, 25.9 grams would be nitrogen and 74.1 grams would be oxygen. So we're going to start out with these as grams instead of as percentages. And you can do this whenever you're given percentages. So here I have 25.9 grams of nitrogen, and I'm assuming to have 74.1 grams of oxygen. So I'm going to put these both over 1, and what we're doing first is we're going to find the moles of each element in our compound. So I'm going to divide each of these by the molar mass of the respective elements. Now, I do not know in my compound what the subscript will be for nitrogen or for oxygen, so I definitely cannot assume that it's diatomic. And remember, it's only diatomic when it's the element by itself for nitrogen and oxygen. So some students want to assume it's diatomic. So here we're going to use 14.01 grams. You notice grams cancel out, 1 mole. And then 16.00 grams and 1 mole. And again, the grams cancel out. So we're going to take each of these and calculate how many moles we have of each. Now, when I do this, I want to keep maybe 3 or 4 places past the decimal. So do not start rounding for significant figures. If you do, sometimes you lose important insight into the problem. So we have 1.8487 moles. So I did not round that to 3 significant figures. And then we have 74.1 divided by 16 gives us 4.6313 moles. Now Nitrogen has a smaller number of moles, so we're going to get this is a ratio to nitrogen. So we're going to divide each of these by that number. Notice in each case the moles cancel out. This will obviously be a ratio of 1. It's 1 to itself. And then if we take that 4.6313, divide that by 1.8787, we get 2.5. So at this point, you should either get a whole number or you should get something that's close to a half. If you're getting something very different, like close to a quarter or 3/4 or something like that, then I would double check to make sure you didn't make a calculation error. Make sure you're using the correct molar mass of each of your elements and that you didn't make a mistake like assuming one of them was diatomic or something like that. Now, this is what the steps we're talking about when they say, when necessary, multiply the subscripts by 2, 3, or 4 to get whole numbers. So this is a situation where we do not have whole numbers. So you've never seen a formula look like this where you have N1, O, 2.5. You've always seen whole numbers as subscripts in your formulas. So we're going to multiply each of those subscripts by 2 to get N2O5. Okay, so now we have ratio of whole numbers, and for every 5 moles of oxygen, there's 2 moles of nitrogen. Okay, so one thing to remember is, like we said, you need to make the subscripts whole numbers. In this case, we multiply by 2, and that's what we just did. Okay, so let's look at another problem now. So here we have a problem with ibuprofen. So this problem tells us we have a sample containing 78 grams of carbon, 9 grams of hydrogen, and 16 grams of oxygen. So remember in our last problem we were given percentage. This time we're given grams. So we're going to start with these. We do not have to calculate percentages. So we can start with 78 grams of carbon and then 9 grams of hydrogen and then 16 grams of oxygen. So we're going to do like we did before and convert each of these to moles using our molar mass from our periodic table. And you notice in each case the grams will cancel out, and then we're left with moles. Okay, so now I'm going to calculate the number of moles we have of each. So we do 78 divided by 12. That gives us 6.4946. So again, I keep about 4 places past the decimal. I do not round yet. And we get 8.9286 moles of hydrogen. And then we have 1 moles of oxygen. So we notice here that the smallest number is the number of moles of oxygen. So we're going to divide each of these other numbers by 1. So you notice here we have something very close to a half. So we're going to make that 6.5. Here this is very close to whole numbers. So we're going to make that 9. And then obviously this is going to be 1. So we get C 6.5, H9, O1, and we're going to multiply each of those subscripts by 2 to get C13, H18, O2. So that is our formula for ibuprofen. Okay, so those are how we do empirical formulas. So what I want you to do now is do one of the problems on your sheet.